Hello, my name is Bruce Barclay and I'm a student here at J-Tech Automotive Technology School. And today we're going to talk about how to use a scan tool to troubleshoot engine performance related issues. First of all, a lot of people a lot of us think you have to have an MIL light, which means is the same as a check engine light, in order for you to have a poorly performing motor, and that's not the case at all. You can have a poorly performing engine and the MIL light will not come on. So when you have an issue like that, you have to rely on your customer to tell you what the engine is doing, and you have to verify their concern before you start your diagnosis. So you don't necessarily have to have a check engine light or an MIL light in order for you to actually need to do these things. Okay, so some of the symptoms could be of a poorly run engine. Could be like stalling, it could be running rough, it could be dying when they're trying to accelerate, it could be that it just doesn't run smoothly when they're idling, or it dies, the engine dies when it comes to a stop. Numerous things could be the reasons why they're bringing it to you. So you have to really connect with the customer and really ask them what's going on with the vehicle, so that and test drive the vehicle yourself so you understand it. Okay, so we're going to go ahead and take a look at some of the things that we could be seeing, or we're going to need to be looking at when we're trying to fix the car. First thing we want to look at is fuel trim, and here we have what's known as long-term fuel trim test average, and we're running right at about 99 on both of those, and that's pretty good. And what long-term fuel trim is it takes many drive cycles and it adds them together and averages them out. So, and you always want to be right around 1 or 0 with this, and this engine is running pretty decently at the moment. Then there's also short-term fuel trim, which takes a snapshot of how the engine's performing with the fuel, and once again you want to look for the same numbers. You want to look at your O2 sensors, which are here. This is our O2 sensors. We have numbers for them at the moment. So we're showing that the O2 sensors are actually working, and you want to verify these with your manufacturer specifications. And then there's a loop status. Loop status is currently closed. It'll open when you start driving the car and when you're running the car through acceleration, and it'll close once it reaches wide open throttle. Then you have rich and lean concerns. When you have rich and lean concerns, what you're going to see is either negative numbers or positive numbers on your fuel trims. Then you can look at injector pulses, which we see right here. We're seeing 2.82 or 2.81 milliseconds, and that's basically telling us how long our fuel injectors are staying open and spraying fuel into our engine. And also the fuel injectors work on something called pulse width modulation. So you can use all these numbers to help troubleshoot and diagnose, or help lead you to what's causing the engine to run poorly. One last thing I want to say about this thing is the engine management computer is striving to make the engine run at something's called a stoichiometric ratio, which is 14.7 to 1. That is 14.7 parts fuel to 1 part air, and that's the way that the engine runs the best at its best peak of fuel efficiency. So now we have the tools that we need to use in order to diagnose our problems, and there are many other things that we can do as well, like using scopes and other stuff, but this is just basically cracking the nutshell. There's a whole lot more to it than that, but anyway, I appreciate you watching the video today. Thank you very much.